Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to wrap up circles and we're going to talk about circumference and arc length. The good news, we've already talked about circumference. The good news, we've already spoken about arc length. I've given you all of these formulas already. In fact, I went above and beyond. We know about circumference, we know arc length, and we also know sector area, which is what we're going to really hone in on next chapter. So you're ahead of the game. So this should be an easy lesson. Just a nice little reminder, okay, if you guys remember, we have my center here, okay? Give me 1 second, please. Okay, guys, so like I said, you have a center here, okay, P. The distance from the center to any point on the circle is my radius, and the chord that goes through the center is my diameter. So circumference is the distance around a circle. The formula is based on the following fact. A lot of times teachers don't teach this, guys, so I want to make sure you understand why it is that we use 2 pi r or diameter pi. Pi, okay, it's a Greek letter. We know we've worked with it, but pi is rounded off to 3.14, or sometimes you can use 22/7. A lot of times students will just take that for granted, they'll accept it, and they just move on. A lot of teachers just teach it and move on. I'm going to take a few seconds just to explain why. On any circle of any size, if you take the length of the diameter, okay, if I were to take this AB and make it malleable, and I were to wrap this AB around the circle, I would literally wrap it around once, twice, 3 times. And every single time, there's going to be this little gap here. That little gap is the 0.14, etc., 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 attached to pi. That is why we use pi. The diameter of any circle of any size, the diameter of that circle wraps around the circle 3 exact times with a little change left over. That's where we get this 3.14. That is the change left over. That is why we use 2 pi r or diameter pi to solve for the circumference of a circle. Okay? Very, very important that you guys really understand why it is we use pi. I'm sure none of you have ever been taught that, and that is a shame. Okay, that is the exact reason why we use pi. When they were coming up with figuring out circumferences and areas of a circle, they didn't quite know how to do it. So the Greeks realized, hey, wait a second. The circumference wraps around 3 times and we have this left over. They did the leftover ratios over and over again, and they kept coming up with the same leftovers. So they created pi. Yes, sir?
I understand like it goes around 3 times, like why
0.14, because that is the percent of the circle left, always. Always. It's a ratio. They took the ratio of the diameter wrapped around 3 times with the leftover portion. And that ratio was 0.14, etc., etc., etc. Okay? All right. So, using circumference, we can find what's called arc length. Please remember, guys, there's a big difference between arc length and arc measure. Arc measure is this straight up. The central angle equals the degree measure of the arc that is directly opposite of it. That's arc measure. But arc length is the length of an arc, okay? The length. And the length of an arc is equal to the circumference of the circle times the fractional part of the circle determined by the arc. What does that mean? That means that the length of arc AB is equal to the central angle divided by 360 times the circumference, pi d, or 2 pi r, depending on what they give you. Or the length of AB is equal to the arc measure of that particular arc you're trying to find the length for, over 360 times pi d, or of course 2 pi r, okay, because this is circumference. Now, Mr. Morrow, are these two different things? No. Remember that the central angle is equal to the arc that it intercepts. So sometimes they're going to give you the central angle measure. Well, you put that over 360 times circumference, you find your arc length. Sometimes they're going to give you the arc measure of the arc they want you to find the length for. Well, you put that arc measure over 360 times circumference, and you have your arc length, literally. Does that make sense, gentlemen? I'm going to take that as a yes. Okay. All right. Awesome. All right. Now, find the length of AB. Okay, perfect example. In this case, they gave me the central angle. So, central angle over 360 times the circumference. In this case, they only gave me the radius. So I have to multiply that by 2 is 2 pi r. So this is going to be 36 pi. Well, cancel out the zeros. Cancel out the 36. I've got 6 pi as my answer. You can leave the answer in terms of pi. If you read the directions, okay, if I tell you find the arc length and round to the nearest tenth, then go ahead, please, and round to the nearest tenth. If I just say find the arc length, then I'm leaving it up to you. You can leave it in pi, which I would do, or you could go ahead and multiply 6 times 3.14. If I tell you leave in terms of pi, then I'm specifically telling you to leave in terms of pi. Okay? But please know the nuances there. What if I reverse it? What if I say find the radius of a circle whose circumference is 80 pi? Well, that should be pretty easy, right? What does circumference equal here? Circumference equals 2 pi r, correct? Doesn't circumference, didn't I tell you it equals 80 pi? That equals 2 pi r. Go ahead and divide by 2 pi. What's my radius? What's my radius? 40 units. Gotta know the formulas. That's why geometry is so intense. Not only do you have to think and use logic, but you have to use the formulas. Okay? Alright. Find the length of each arc. Okay. I want to find the length of this arc right here. So, I have my arc measure. 30 over 360 times my circumference. So it's 2 pi r. So it's 48 pi. Get rid of this. That goes to 12. 48 divided by 12. That's going to be 4 pi. It's that simple. What happened, man? Talk to me. 30 over 360 times 48 pi. I got rid of the zeros. 3 goes into 3 one time. 3 goes into 36 12 times. 48 divided by 12 is 4 pi. No, it's okay. You're human. Thank you for asking, my man. Thank you. How about this guy right here? Well, this time they gave you a central angle. So 105 divided by 360 times circumference, which is going to be 2 pi r, which is 24 pi. Now remember, you can use calculators if need be. But I like to reduce things first, me personally. Okay? 5 goes into 105 how many times? 21 times. 5 goes into 360 how many times? 72 times. Okay? Does anything go into 21 and 72? 70 does not go into 21 and 72. 3 goes into both of those. 3 goes into 21 7 times, and 3 goes into 72 24 times, right? So the 24 cancels the 24. My answer is 7 pi. If you wanted to do it with your calculator, you just go 105 times 24 divided by 360. That gives you 7 times pi. 7 pi is your answer. Does that make sense? Now the bell's going to ring. I'm going to continue and finish the video and post it. Okay? Let me pause real quick. Okay, guys, so let us continue. The diameter of a wheel of a bike is 70 centimeters. How far will the bike travel if the wheel rotates 1,000 times? Well, think about it. Every rotation of the wheel means that it went one full time around that whole circle. So that means that the distance that it traveled was equal to the circumference. So let's first find the circumference of the wheel. And circumference here is going to equal diameter pi, so 70 pi. Okay? 70 pi. That is the distance of one full rotation of this circle. So how far will the bike travel if the wheel rotates 1,000 times? Well, let's go ahead and take the distance around that circle, the circumference, times 1,000. So this would equal 70,000 pi. Usually when they're looking for distances, though, like this, they want real numbers. So it'd be 70,000 times pi, which would give you 21,000, I'm sorry, my bad, 219,911.49 centimeters. Okay? How many revolutions will the wheel make if the bike travels 15 meters? Okay. Let's pay attention to this. They gave you the original diameter in centimeters. If I want to recalculate this, though, using meters, I've got to turn 70 centimeters into meters. Okay? And 70 centimeters into meters, I've got to move my decimal 2 places to the left. So first thing we want to do is recalculate the diameter in meters. So 70 centimeters will equal 0.7 meters. Okay? And now I want to find the number of revolutions that the wheel will make if it travels 15 meters. Well, 15 meters equals the circumference times the number of revolutions. Well, 15 equals the circumference, which is diameter pi, so 0.7 pi, times the number of revolutions. Divided by 0.7 pi, divided by 0.7 pi, and 15 divided by 0.7 pi equals 67.32 revolutions. That's how many times it went ahead and spun around. That's how many revolutions it had. Okay? Does it make sense? Awesome. And that's it. Thank you very much. Have a great day, and I hope you learned a lot. Bye-bye. I have made a very grave error, and I apologize sincerely. I am wrong. Centimeters to meters, like I tell you guys all the time, focus, pay attention. It's only one place to the left. It's 7 meters. So let's do that again, and I apologize sincerely. No excuses. 15 meters equals, that's the total distance that it traveled, okay? Equals the circumference times revolutions. 15 equals 7 pi times the revolutions. Divided by 7 pi, got 15 divided by 7 pi, that equals 6.7 revolutions, not 67. That is my bad. I apologize sincerely, and I hope you can forgive me. Now, I hope you learned a lot. Have a wonderful day, and thank you. Bye-bye.